Hey, this is a quick lesson on how you solve one-step inequalities. So in your first lesson, you saw what inequalities are, you talked about those, and you talked about how to graph them. So let's talk about how to solve them. It's kind of like solving an equation. So inequalities look like an equation, but where the equal mark is, you're going to see an inequality. So you're going to isolate your inequality statement the same way that you would isolate a variable in an equation. So if I read this as x plus 3 is less than 15. I want to know all the values that x can be, where if I plug those values in and add 3, that I get values less than 15. So I'm going to isolate this x just the way I did if this was an equal mark. I'm going to subtract 3 from both sides. I'm going to work down the board. These cancel out. I'm going to bring down my x. I'm going to bring down my inequality symbol. And this solution of answers would be anything that I could plug in for x, if I choose numbers that are less than 12, would work up there in that original statement. So anything that I plug in up here, like 11 plus 3, does that give me numbers that are less than 15? Yes, it does. So let's look at number 2. Same thing. It's a subtraction inequality. I'm going to solve it. My variable's over there on the right. I'm going to isolate the inequality for the variable. I'm going to do the inverse operation of subtracting 6, so I'm going to add 6. I work down the board. 20 plus 6 is 26. So my answer would be 26 greater than y. So I could reverse that and write it like this, where I bring y over to the left and write 26 over to the right, and my inequality still needs to be pointing to the 26. So what this means is any answers, any numbers that are less than 26, I can plug in up here to give me a true statement. So if I pick one, say 25. 25 minus 6 is 19. Is this a true statement? Is 20 greater than 19? Yes, it is. The only thing that's a little bit different with solving inequalities is when you get into multiplication and division. When you are in a multiplication inequality, when you have to divide by a negative number, you're going to have to switch the direction of the inequality. But that only works when you're dealing with dividing or multiplying by a negative. So let's look at these two inequality examples that I've given you here. The first one is 4 times x is less than 12. So I'm going to solve this by doing the inverse of multiplying by 4. So that means I'm going to divide by 4. And of course, 4 divided by 4 is 1x, and I write that as x. So that means I divide that out over there. 12 divided by 4 is 3. And my solution set of answers here are all the x values that are less than 3. And that means anything that I plug in less than 3 up here would work. Let's say I pick something like negative 1. 4 times negative 1 is negative 4. Is that less than 12? Yes. So it works. But when I get into an inequality where I have to divide by a negative, watch what happens. I have to switch the direction of the inequality. So this is negative 4x divided by, less than 12. I need to divide by negative 4 on both sides. Dividing by a negative divided by a negative is positive. When I divide by a negative, this changes its direction. And my answer this time is x is greater than negative 3. So if I take any number that's greater than negative 3, let's say I pick, say, 5. If I pick 5 and plug it in right here, negative 4 times 5, that's negative 20. Is that less than 12? Yes, it works. So what you have to remember about solving inequalities is if you divide or multiply by a negative, you switch the direction of the inequality.